Hello friends, welcome to Yashwantrao Chauhan Maharashtra Open University Nashik, School of Architecture, Science and Technology. Today we are going to discuss upon the program V92 BSc Physics Chemistry Mathematics course S41441 Mathematics 04, which is of groups and rings. Myself Tejasvi Kadam work as an academic coordinator in the School of Architecture, Science and Technology, Yashwantrao Chauhan Maharashtra Open University Nashik. So we will start with the credit 01, which is of groups, unit 01.01 binary operation defined on a set. In high school algebra, various manipulative techniques are studied. Now we are going to discuss about the abstract algebra. Abstract algebra emphasizes on systematic study of number of abstract algebraic structures such as groups, rings, vector spaces, and this list includes about 200 structures. Algebraic structures are the sets with one or more operations defined on that set satisfying certain properties. However, we confine to the study of groups here. Credits 01 and 02 are devoted to the study of groups. A group involves the basic concept of binary operation which is studied in this unit. Now we will see what is meant by binary operation. A binary operation on set G is a function O from Cartesian product of a set G with itself to the set G. That is, binary operation is a function from a Cartesian product of a set with itself to that set. If A and B belongs to G, then AOB must belongs to G. That is, if A and B belongs to G and AOB is equal to C, then C must belongs to G. That is, for any operation on a set G to be a binary operation, if we apply that operation on any two elements from set G, then output of this operation must belongs to set G. In this case, we say that the set G is closed under O if and only if O is the binary operation defined on a G. That is, G is closed under O if and only if O is binary operation on G. We will try to understand this by example. Addition is a binary operation on set of natural numbers. Consider n1 and n2 be any natural numbers, then we know that n1 plus n2 is also a natural number. That is, addition of any two natural numbers is again a natural number. That's why addition is a binary operation on set of natural numbers. But division on natural numbers is not a binary operation. Let us suppose 1 belongs to n and 2 belongs to n, but 1 divided by 2 does not belong to n. That is, if we apply division on two elements from natural numbers, then we are not getting here a natural number. That's why division is not a binary operation. Again, we will see some more examples. Subtraction is not a binary operation on set of natural numbers. Before proving this, we must note one thing, that if you want to prove that some property holds for some set, then we have to prove that this property holds for all the elements from that set. But if you want to prove that some property does not hold on that set, then it is sufficient to show that this property doesn't hold for one single pair of elements. So here we will take 1 belongs to n and 2 belongs to n, but 1 minus 2 is equal to minus 1 does not belongs to n. That's why subtraction is not a binary operation on set of natural numbers. But subtraction is a binary operation on set of integers. Because for every Z1 and Z2 belongs to Z, that is for every pair of integers belongs to set of integers. Subtraction of integers is again an integer. That's why subtraction is a binary operation on set of integers. But it is not a binary operation on set of natural numbers. Suppose 3 and minus 4 belongs to Z, then if we consider 3 minus minus 4, that is equal to 3 plus 4 is equal to 7, which is also integer. Minus 4 minus 3, which is equal to minus 7, that is also integer. That is, if we take subtraction of any two integers, then it is again an integer. That's why it is a binary operation on set of integers. Now we will see the types of binary operation. There are three types of binary operations: commutative operation, associative operation, and distributive operation. Now we will discuss these types one by one. Commutative operation. A binary operation star on a set A is said to be commutative if A star B is equal to B star A for all AB belongs to A. That is, if we get the same output or the result, even if we interchange the sequence or order of the elements while applying the operation, then such a type of operation is called as a commutative operation. Now we will consider an example. Addition and multiplication on the set of real numbers are commutative. To prove this, let us consider any two real numbers. If A and B are real numbers, then we have A plus B is equal to B plus A. That is, while doing the addition, if we interchange the sequence of the elements, we will get the same output. Similarly, while doing multiplication on the set of real numbers, if we interchange the sequence of elements, we will get the same output. That is, A dot B is equal to B dot A. That's why addition and multiplication are commutative operations on the set of real numbers. Now we will see the counter example. Subtraction is not a commutative on the set of real numbers. Consider 3.36 and 5 belongs to R. 3.36 minus 5 is equal to minus 2.64 and 5 minus 3.36 is equal to 2.64. That's why we are getting here 3.36 minus 5 is not equal to 5 minus 3.36. That is, sequence of the numbers while doing subtraction matters the output of the function. That's why for some AB belongs to R, we are getting here A minus B is not equal to B minus A. That's why subtraction is not a commutative operation on set of real numbers. Again, division is not a commutative on R star, that is non-zero real numbers. Here we are considering non-zero real numbers because we cannot divide any number by 0. Suppose 2 and 3 belongs to R star. Here we can say 2 by 3 is not equal to 3 by 2. That is, if we change the sequence of numbers while doing the division, we will get the different output. That's why division is not a commutative operation on R star. Now we will see the summary of the lecture. Let G be a non-empty set. That dot is a binary operation on set G if AB belongs to G implies A dot B belongs to G. This must hold for all AB belongs to G. Star is commutative operation on G if A star B is equal to B star A for all AB belongs to G. In the next video, we will discuss the topics associative operation and distributive operation. Thank you.